In today's data-driven world, managing and processing vast amounts of information efficiently is critical. Welcome to this overview of how to leverage Databricks and Apache Airflow to build robust and scalable data pipelines. This video will guide you through using Databricks for processing large datasets and Airflow for orchestrating and monitoring these data workflows. Databricks is a cloud-based platform that simplifies big data processing and analytics, providing a collaborative environment for data professionals. Built on Apache Spark, Databricks offers tools for ETL processes, real-time stream processing, and machine learning. It provides a single unified analytics platform for data analytics and machine learning workflows. The platform is known for its ability to handle massive datasets with ease, enabling massive scale data engineering. With native support for notebooks, Databricks enables data scientists to create and share their work seamlessly, fostering collaborative data science. Databricks simplifies machine learning lifecycle management from model training to deployment, supporting advanced machine learning and AI applications. Furthermore, Delta Lake enhances data reliability and performance, ensuring your data is always consistent and accessible. Apache Airflow is a workflow orchestration tool that allows you to programmatically author, schedule, and monitor data pipelines. Workflows are defined as code, making them maintainable, versionable, and collaborative. Airflow enables you to manage complex data pipelines, automate tasks, and ensure data processing is efficient and reliable. Airflow uses directed acyclic graphs, or DGs, to represent workflows, showing task dependencies and order of execution. Airflow is highly extensible, with a plugin interface that supports various use cases across different data ecosystems. It excels in orchestrating complex data pipelines, automating tasks, data processing, and machine learning model training. Airflow's user interface makes it easy to visualize pipelines, monitor progress, and troubleshoot issues effectively. Integrating Airflow with Databricks combines Airflow's orchestration capabilities with Databricks' scalable compute power. This integration is ideal for data engineering, machine learning, and analytics workflows, creating a powerful synergy. Using operators like Databricks Submit Run Operator and Databricks Run Now Operator, Airflow can trigger, manage, and monitor Databricks jobs. First, configure an Airflow connection to communicate securely with your Databricks account. Next, define your workflow in a Python file, specifying the tasks and their dependencies within a DG. Then, use Airflow operators to trigger Databricks jobs, such as running a notebook or a Spark job. Finally, monitor the execution of your Databricks jobs in the Airflow UI, tracking task states and logs for complete oversight. To optimize your data pipelines with Databricks and Airflow, consider the following best practices. Deploy Databricks on AWS, Azure, or GCP for scalability and reliability, utilizing managed Databricks workspaces. Tune job resources like number_workers and node_type_ID appropriately, monitoring with the Databricks UI for optimal performance. Implement Airflow's built-in error handling and retry mechanisms to manage failures gracefully. Monitor task states and logs in the Airflow UI, and use Databricks monitoring tools to identify bottlenecks and ensure smooth operation. Secure credentials using Databricks Personal Access Tokens or OAuth tokens for robust authentication. By integrating Databricks and Apache Airflow, data engineers, data scientists, and big data professionals can build robust, scalable, and efficient data pipelines. This combination allows for seamless data processing, workflow orchestration, and real-time monitoring, enabling organizations to make data-driven decisions with confidence. Explore the Databricks and Airflow documentation to further enhance your data engineering capabilities and unlock new possibilities.